Okay, so today we're going to look at AP statistics for your response question, specifically problem 2. Let's take a look at it. So there's this local fast food restaurant, and the manager of the restaurant is concerned that customers may be asking for a water cup, but then they fill it with like a soda or something else, which some restaurants would allow you to do. Like, oh, we'll give you a water cup, and then people go over and fill up their own drinks, and then they take something they're not supposed to take. They didn't pay for it. So in this case, the manager interviews n equals 80 customers and finds out that 23 of them actually fill up that drink with something other than water, like they said they wanted. So let's look at part A. Construct and interpret a 95% confidence interval for the proportion of all customers who, having asked for a water cup when placing an order, will fill the cup with a soft drink from the beverage fountain. Okay, so anytime you do a confidence interval, it's just like doing a significance test. You've got your assumptions to worry about. So first off, identify this as a one proportion Z interval. That's what you're doing. On the AP, they would want you to do that. Um, so let's take a look. Number one, there should have been an SRS performed or a simple random sample. It says that here, that he did a random sample. Number two, the population of all customers at the restaurant should be greater than 10 times the sample size, which in this case is 10 times 80 or 800. There's no way to verify that, so we say this is an assumption. We have to assume that's true. Provided that's true, then you know that the standard deviation of p hat is equal to the square root of p hat times 1 minus p hat over n. So in our case, we would have, now p hat, what is p hat? We should have written it down before. P hat is going to be the number of customers that said they take a soft drink when they claimed they were just going to get water out of the 80 people who were interviewed. So if you divide that, you get about, what do we have here, 0.2875. And so when we go to use that in our standard deviation formula, we end up getting the square root of 0.2875 times 1 minus that gives you about, well, exactly 0.1725 over the sample size of 80. So we should take a minute to estimate the standard deviation of p hat. So we have it. We're going to need it in a minute. And I'm getting about 0.051. Okay. And then the last thing you're supposed to check is for normality. We need to make sure we can use z-scores and things like that. So in the case of proportions, you check that n times p hat and n times 1 minus p hat are both greater than or equal to 10. That's what we need to know. So in our case, we'd have 80 times 0.2875, which is 23, which is definitely greater than or equal to 10. Then we have 80 times 0.7125, which equals 80 minus 23, or 57, which is also greater than or equal to 10. So therefore, p hat is approximately normal. Okay, so now you're set. Now that you have that, you're ready to build your confidence interval. So a one proportion z interval, which is what we're making, looks like this. It's always p hat plus or minus z star times the standard deviation of p hat. Sometimes if you were to look in the textbooks, you might see this, z star, and then you'll see the standard deviation formula here. So either way is fine. All right, so p hat in this case was 0.2875 plus or minus, we'll leave z star blank for a minute, and we calculate our standard deviation to be 0.051. All right, so just in case you forgot, this problem wanted a 95% confidence interval. So we draw a little normal distribution here. We put 0.95 in the middle, and we just need the z-score that goes here. So to figure that out, we will find that the area in this corner is 1 minus 0.95 over 2. 1 minus 0.95 divided by 2 gives you about 0.025. And so if you want to, in your calculator, your T84, use an inverse norm. So go to second distributions, the third one down, inverse norm, 0.025. Leave the mean and standard deviation at 1 since or 0 and 1 respectively, because we want a z-score. We will get here negative 1.96. So in the confidence interval, you just put the positive version of that. There you have it. Now I'm just going to estimate this confidence interval. And when everything's said and done, I am getting a confidence interval that goes from 0.18754 up to 0.38746, or about 19% to about 39%. So what can we say here? So go back and interpret this confidence interval in the context of the problem. You'd want to say something like this. So I would just look back at part A here, and let's use a highlighter for a minute. Let's look at, we are 95% confident that the proportion of all customers who, having asked for a water cup when placing an order, but will fill the cup with a soft drink, is somewhere between about 19% and 39%. So that would be a good way to interpret this confidence interval. Let's look at part B of the question. Part B says the manager estimates that each customer who asks for a water cup and fills a soft drink costs the restaurant 25 cents. So he then goes on to say that suppose in the month of June, 3,000 customers ask for a water cup when placing an order. Use the confidence that we just made to give an estimate for the cost to the restaurant for the month for the people who ask for a water cup and create a soft drink and get a soft drink instead. Let's take that part just to a new page for a minute. Let's copy this. Let's go to a new page and paste this. So here we are. So you have to think about it this way, right? We have a confidence interval we built. Confidence interval, don't lose track of it, is right here. There it is. So let's just round it. Let's go 0.188 to 0.387. So let's do that. So our confidence interval from part A is 0.188 to 0.387. That's our 95% confidence interval. And so that's the proportion of people we think who are going to ask for a water cup but then get a soft drink. So I guess the number that sticks out for me is that the restaurant had about 3,000 customers ask for a water cup. So if we were to take this 0.188 and multiply it by 3,000, and also take the 0.387 and multiply that by 3,000, we would get an interval that would tell us the approximate or the number of customers we would expect to ask for a water cup, which is somewhere between 564 and, hold on a second here, and 1,161. Oop, that's a 1. Let's fix that. So what do we know then? Each one of those customers costs the restaurant 25 cents. So now I'm going to take both of these numbers. I'm going to take the 564 and multiply that by 25 cents per customer. And I'm also going to take the 1161 and multiply that by 25 cents per customer. And if I do that, I would get a confidence interval, which would give me an estimate for the number of customers or the amount of dollars the restaurant loses in this month. So I'm getting a low end of 141 and a high end of, divide that correctly, I'm getting about 290.25. So we're 95% confident that the restaurant loses between $141 and $290 per month by giving cups to people who say they want water, but in fact they go over and get a soft drink. All right, thanks for watching.